All right, we're going to talk about section 2.1 today. This is frequency distributions in our graphs. So we're going to be doing some graphing. Oftentimes in statistics, a lot of data is represented in some form of a graph. So in order to do graphs, oftentimes we have to do a frequency distribution first. So it's a table that shows classes or intervals of data with the count of the number of entries in each class. A frequency distribution then tells us the frequency, which is the number of data entries in each class. Each class has an upper and a lower class limit. Not surprising. The lower class limit would be the least value, the least number. Of course, the upper class limit would be the higher number. So in this case, the lower one is 1, the upper one is 5. The distance between the lower and the upper is called the class width. So in this example, 5 minus 1 would be 4, so the class width here is 4. And the difference between the maximum and the minimum is called the range. So how do we construct a frequency distribution? Well, first thing we need to do is decide on the number of classes. That's usually between 5 and 20, so that the patterns are easier to detect. We need to determine the class width, so we do that by finding the range and dividing it by the number of classes. And we have to round oftentimes. The class limits, you can use the minimum data as your lower limit, and then from that we use the width to help us find the next limit. And then we find the remaining upper limits from that data as well. You'll see in just a minute. So also then we use tally marks just like you used to when you were a kid. Oftentimes just tallying up the data, and then we're going to count them up for count up the tally marks for each frequency. So basically, to start off, we're going to need the class, going to need tally marks, and we are going to then need the frequency. Oftentimes this tally mark column is left off, but when you're actually the one creating it, it's beneficial to have that tally mark on the chart, at least to begin with. If you were presenting this data in front of a group of CEOs or your boss, I would not include those little tally marks. So then we're going to look at the range. The range of our data is 405. That's our high point. 155 is our low point. So we have 405 minus 155, which is equal to 270. We're going to take that 270 and we're going to divide by the number of classes. How many classes does this have for us? Well, this time we're in good shape because it tells us we have 7 classes. It also tells us that we're looking at 30 pieces of data. And so we really didn't talk about what this data represents. So this is a list of out-of-pocket prescription medicine expenses for 30 adults in a recent year. So these are medical expenses, prescriptions. So we're going to take 270, we're going to divide it by the 7 classes that it tells us we have, and that'll be approximately 35.71. So we are going to round that up to 36. 36 is our class width. So there will be 36 numbers in that group. Right, so how do we find the actual class, upper and lower class? Well, we know the lower class of the first class is going to be 155. And so to find the lower limit of the next class, we're going to take 155 and add our 36. And that's going to give us 191, which again is going to be the lower limit for the second class. So if the lower limit to the next class is 191, that means that the upper limit on the first class is 190. You can't put the same number in two groups, so it either belongs to the first class or it belongs to the second class. So in this case, we're finding lower limits every time. So to find the next lower limit, I would take the 191, add 26, and my next lower limit is 227. So 227 means the upper limit on the previous group was 226. If I continue in this manner, I end up with the next group starting at 263, then at 299, then at 335, and then finally the seventh class is 371. Those are all lower limits. So the upper limit then would be one less than 263, so 266, or 262, sorry, 298, 334, 370, and 406. And then the next thing we'll do is take a look at our data. And from that data, we will start just calculating and just tallying it up. So first piece of data was 200, so that would go into the second class. The next piece of data is 239, that would go into the third class. The next piece is 155, it would go into the first class. 252 goes into class 3, and if we continue in this manner for the sake of time, we would have 3 in the first group, 2 in the second group, 5 in the third group, 6 in the next group, 7 in the next group, 4 in the sixth, and 3 in the last group. So now, just again to double check your work, make sure you do have 7 classes, 1, 2, 3, 4, 5, 6, 7, and indeed we do. Then the next thing you want to do is make sure that when you add up the data, that the sum of the frequency equals 30. This way you make sure that you did not leave out a piece of data unintentionally. So 3 plus 2 is 5, plus 5 is 10, 16 plus 7 is 23, 27, 30, so we do indeed have 30 pieces of data, which is good. So some more things that we need to find then that are going to help us build any kind of charts that we want. So some of the other things that we're going to need is the midpoint for each class and relative frequency. And then we also have cumulative frequency. So to find the midpoint, that's exactly like it sounds. It's an average. It's the midway between the classes. So if I look at the lower class limit and the upper class limit of the first group, lower class was 155, the upper was 190, add those up, divide by 2, and I end up with 172.5. And again, this is the midpoint of the first class. I can do that for each one of the classes and find out what the midpoint of each one of those are. So 191 plus 226 divided by 2 is equal to 208.5. Relative frequency is basically like your percent. It's going to be a percent, however, that we put in decimals. So it's not going to look like a percent because it is going to be a decimal representation. And basically then it looks at the part out of the whole. So for each class, how many times does it occur? And out of the total sample size. So for the first class, we have 3 pieces of data. There are 30 pieces total. So 3 divided by 30 is 0.1. So the relative frequency is 0.1, which if we were thinking about that in terms of percent, that would be 10%. So roughly 10% of the data falls in the first class. That's what that will tell you. Cumulative frequency, again, sounds just like it is. It's going to sum all of the frequencies from that class and the previous classes, so that when you're finished, the cumulative frequency of the last class is equal to your sample size. So using the same example from before, let's find the midpoint, the relative frequency, and the cumulative frequencies. And of course, I would use a calculator to find some of this information as needed. So the first class is 155 through 190. And we said the frequency of that was 3. The next one is 191 through 226. Frequency was 2. 227 through 262 has a frequency of 5. 263 through 298 at a frequency of 6. 299 through 334 has a frequency of 7. 335 through 370 not sure what I hit. Okay, through 370 at a frequency of 4, and 371 through 406 at a frequency of 3. That's all the information we had from the previous data. I'm not sure what's going on here. Looks like it's cut and pasted from the previous thing. There we go. See if we can go back a little bit. Sorry about that. So let me just fill in the chart again. 335 through 370, 371 through 406. This was 4, this was 3. And again, that's all information from the previous chart, frequency distribution that we made. Next, we're going to find the midpoint. Again, that's the 155 plus 190 divided by 2. So 155 plus 190 divided by 2. And that ended up being 172.5. The frequency, I'm sorry, that's not frequency, it's relative frequency, is 3 divided by 30, which we said was 0.1. The cumulative frequency this time is 3, because we're adding the frequency with anything previous. Well, there's really nothing previous, because it's our first class. So then for the next one, again, we're going to do 191 plus 226 divided by 2 for the midpoint, and that gives us 208.5. Relative frequency is 2 out of 30, which is equal to, so again, unless you know that by hand, we can pull up our calculator. Okay, so again, if you have your calculator, I would suggest you use your calculator. So 2 divided by 30, we pull up our calculator. 2 divided by, oops, not 22, 2 divided by 30 would give us 0.066, or around 7%. So 0.07. Cumulative frequency now is going to be the 3 from the previous plus 2 from the new one. So this would be next class, 227 to 262. We had 5 entries. If I do the midpoint, again, that's going to be 227 plus the 262 divided by 2 is 244.5. And the frequency this time was 5. So I'll just do it at the same time. So 5 divided by the 30 is 0.1666. So midpoint for the third one, we said was 244.5. Relative frequency was 0.1666 or 0.17 when we rounded. Cumulative frequency, 3 plus 2 plus 5 is now going to be 263 to 298. Again, for the sake of time, we give it the midpoint of 280.5. A relative frequency of 0.2. Cumulative, 10 plus 6 is 16. Next one, 316.5. 0.23 is the relative frequency when I do the division, 7 divided by 30. Cumulative is equal to 23. 16 plus 7. Next one, midpoint is 352.5. Relative frequency is 0.13 when we round. And cumulative frequency is 27. Last class, midpoint is 388.5. Relative frequency is back to the 0.10, coincidentally. And cumulative frequency, 27 plus 3 is 30. And again, this number should be the sum of your frequency. Oops, not sum of frequency in this case, sorry. This 30 is actually your n or your sample size. So that's a good thing. Of course, we want that to equal the sample size. If I were to add up the relative frequency, that should equal 1, again, because we're looking at percents. And if I add up, of course, just the frequency in general, that is going to give me the 30. So why do I need all of this information? Well, again, lots of times it's to help us build charts. In this case, we're going to construct a histogram. So if I construct a histogram, that looks like a bar graph, similar to the bar graph here on the right. You've all seen these before. Frequency is on the y-axis. The data values are along the x-axis. The measure on the vertical axis is also the frequency. And the consecutive bars need to touch. To be a histogram, those consecutive bars have to touch. Because consecutive bars must touch, we must begin and end at the class, what we call class boundaries. class boundaries. So, using our data, we're going to construct the histogram. So we'll have an x-axis and a y-axis. X, of course, is horizontal, y is vertical. Along the y-axis, we have the frequency. In this case, our highest frequency went up to 7. Our lowest one then is at 1. So starting at 1 and ending at 7. Along the y, we do put a break here in the graph. That's a very typical thing. That's what that little wiggling mark means, which is a break in the graph. This way it knows we don't start at the beginning. And then, depending on how you want to construct this frequency histogram, you can use either the midpoint or you can use the beginning and the end value. So, oftentimes you'll see it either way. Our first class has a frequency of 3. So it's going to have a bar graph that goes up to 3. The next one has a bar graph that goes to 2. Then we go all the way up to 5. Then we're going to go up to 6, up to 7. Then we go back down to 4. And then the last one is back to 3. So it's probably easiest, again, if we go to the midpoint. So if we look at the midpoint of each one of these bar graphs, that's going to coincide exactly with my midpoint on my other graphs. So this would be 172.5, 208.5, 244.5, 280.5, 316.5, 352.5, and then 388.5. Oftentimes you will see the number on top of the bar as well. So 3, 2, 5, 6, 7. You'll also see a title. Sorry. You'll also see the title, which the title of this one
would be Out of Pocket Expenses.
You can also construct the frequency using an upper and a lower bound. So depending again on what you want to use. So if I did that, I can have my upper and my lower bound, and I can use, say, the 155 point, oh, I'm sorry, 155, 190, oh, that would be 191. 191, 227, 263, 299, 335, 371, and then 40. Again, this break in the graph is because we don't start at 0. We start at 155.
So mathematically, that break shows that gap before we start. You may also see decimals instead of whole numbers here. So instead of 155, you might see 154.5 to 190.5. So again, instead of 155 and instead of 191, you may see decimals. It depends on the data in a lot of cases as to what you're trying to demonstrate. Depends on your audience
as to what you're trying to demonstrate. If you use the midpoint, then that's pretty easy to understand, particularly in this case because it is money. So rounding it to 0.5 is like 50 cents, so that makes sense. A lot of times it truly depends on who the audience is for the graph you're trying to make. Right. We have a couple other examples for some graphs to go with this. So the next one is a frequency polygon, which is a line graph that emphasizes the continuous change in frequencies. So this is going to give me the change in frequencies. So again, they're going to be very similar. You'll still see this break. Along this vertical axis is still your frequency. So we still have from 1. This time, because we're doing a polygon, we have to start at 0 so we can show
where it starts and ends. We're also going to end at 0. So that's important this time because labeling the y-axis is going to be important. If we look again at the midpoint, which makes sense, the first midpoint we're going to use is 172.5. Then again, we're going to use 208.5, 244.5, 280.5, 316.5, 352.5, 388.5, and then this is going to be back to the 0, so we actually won't be there. And again, the reason we have to do that is so that when we start at 172.5, we're really at 2. No, we're at 3, sorry. So 172 is at 3. Well, it has to show an increase from 0. So if nobody had any expenses, we would be at 0 frequency. Then we'd have to show the jump up to 3. Then at 208, we're going to be down to 2. At the 244, we're going to be up at 5. Then up to 6. Then up to 7. Then back down at 252. We're going to be back down at 4. And then back to 3. And then as I draw my lines, preferably straight, then we can see the dip and the changes as they go along. And again, the dots are frequency. So this top dot would be at the 7 mark. And then the only thing left to do then is to find this first and last point. In order to do that, if I take 205 and I subtract 172.5, then I end up with, if I can do the math correctly, 36. Again, my class width should be what it is. That makes sense. If I do my class width, then if I take 172.5 and I subtract the 36, that'll get me this lower point, which is 136.5. And likewise, if I take the 388 and I add the 36, that will give me 424.5 for the last value. So it has to do with the fact that we have to start out and show the jump. And then we want to end as if there were no expenses. So nobody's paying
424.5 out of pocket.
May or may not be true, but that's what this graph is showing us. And then don't forget, we also have to right. So out of pocket. Technically, it's medical pharmacy expenses. Depending again on your audience, you might need to make that a little more specific. A relative frequency looks just like the regular histogram. The difference this time is instead of along, you see we now have relative frequency rather than the just frequency. So along your y-axis, we have a cut here still, but now your top value is going to be 1 because it's 1%. So this would be 0.5, this would be 0.75, this would be 0.25. We can also say, if we don't like these numbers, we can also say, all right, the highest one is really 0.23 if you look at my frequency. So I can actually spread out my scale a little bit more, and I can change my scale up. So I'm going to redo this, and I'll change the scale again. Sometimes that looks better. It's going to make your bar graphs look a little higher. So I'm going to delete this. And delete these so I can rewrite them. Right. So if we know the highest one is at 0.25, now we can spread it out a little bit. We can call this 0.05, 0.10, 0.20. And that just spreads out that Y scale. So the first time, our first class had 10% of the data, 0.1. The next one was 0.7, which again will be between the 0.1 and 0.5. Next one is a little bit more than 15. So it's going to be 0.17. Then we go up to 0.2. Then we go back, but no, still up to 0.23. Then we go down to 0.13. And the last one is back at 0.1. And then again, depending on where you want to put your X scale, if you want to do midpoints again, you can do midpoints. If you want to do a lower and an upper bound, you can do that. Let's do lower and upper bound. That would be 150, 4.5, 190.5, 226.5. Again, if we're using just the actual decimal representations, 262.5, 298.5, 334.5, 370.5, 406. Again, the reason they round to the decimal in this case is because your frequency ends on a whole number, and so by stopping the bar right at that decimal, you're really not double dipping into the number that would maybe hit that border point, that boundary point. You have to read the directions, particularly in MyMathLab, and see what it says. Does it say to use midpoints? Does it say to use the data value itself? Does it say to use an upper and a lower bound? Does it say to use relative frequency? Does it say to use regular frequency? So there's just a lot of things you're going to have to read when you do your homework problems. Okay? And again, we always do put a label on this. So back to out-of-pocket expenses.
And again, usually that is right up here at the top. All right. Next type of graph that we have is a cumulative frequency graph, sometimes called an ogive. Basically, again, it looks like a dot graph, very similar to the frequency polygon, but this time it's going to show relative or cumulative frequency along the side here instead of regular frequency. We do have to start still at 0 this time on the Y. Because this is cumulative and we know there are 30 points, we're going to have to end at 30. And again, because we start at 0, then we're going to use the 154.5, the 190.5, the 226.5, the 262.5, the 298.5, 334.5, 370.5, and 406.5. Okay, at the 154, we're at 0. Then we bump up and we're at 3, and then 5. Then we're looking at the the cumulative frequency. Then we jump up to 10. Then we jump up to 16. Then we jump up to 23. Then we jump up to 27. And last, we're at 30. So this one does sort of look like a straight line, but there are a little bit of dips in it. If you look in your book, you can sort of see the end. Sort of see a better picture. But this would be 30 because that's your total value when you're finished. Total value. And that's an ogive. And again, make sure that you put a label on it. All right. So that wraps up section 2.1.